Good morning, Year 12. We're going to be looking at the data that we got yesterday from our experiment. I'm really sorry, I couldn't predict the weather. I thought maybe it'd be a nice opportunity for you to get out in the garden, but obviously we've had the most rain we've had in maybe 2 or 3 weeks. So hopefully, I think most of you actually managed to get quite a lot of data. Unfortunately, only one of you did more than one sample, so we'll use that today in the lesson. So when we take data at A-level biology, we're going to be thinking about the statistics that we take from that. So there's 2 different types of statistics. We've got descriptive statistics, and they are things that describe the data that you've got. So averages, range, standard deviation, and standard error. So we're going to be looking at specifically standard deviation today. The other type of statistics that we've got are inferential statistics. They allow you to infer something from the data. They also allow you to actually work out whether it's down to chance or not. These are really useful in biology and in other sciences as well. They really help you to see, actually, is this just a fluke, or has what I've provided made a significant difference to whatever test you're doing? And these are the other types of tests. We will come across them through the biology course. We've got one called the chi-square test, the Spearman's rank correlation coefficient, that's a bit of a mouthful, and the student t-test. So we'll be having a look at those later on in the course, but they're just to remind you. So like I say, we're just going to look at statistical tests in terms of standard deviation today. So during the course of today's lesson, I'd like you to jot things down as we go. I'd like to see at the end of the lesson some images that you've taken of your notes, so that I can see that you're working to the good standard. So the first 2 questions that I'd like you to add on to those notes is, what do you think the average height for females in the UK is? And then underneath that, I'd like to think about what range would be classed as a normal height range for adults in the UK. So pause the video, write those 2 things down, and then we'll go through why I want you to do that in a minute. Okay, so let's see how you did with your guesses then. So in the UK, the average height for a female, adult female, I should have said it originally, is 63.8 inches. That is just under 5'4". So how did you do with that one? And then the range, as you can see, the vast majority of females in the UK fall within this category here. So you've got your percentage of population at the side here. You can see that most people fall into those categories there. So normal height range in the UK is between 5 foot and 6'8". Then you've got the extremes of the shortest people over here. Not many people in the country, less than 2%, are 58 inches, and again over here less than 1% of people hit over the 71 inches. So as you can see, we've got a spread of data. So how that relates to what we've been looking at, we're looking at variation, how organisms vary, and obviously we've got variation in heights. Now this type of data, when we can see it lined like this, it's called a normal distribution, as in lots of people are in close to the average and not many people are at the extremes. These types of graphs are sometimes called bell curves just because of the shape of them, but they don't always have to look like the one on the previous slide. As you can see, distribution 1 is very tall and thin, so there's not much difference from the mean. So the mean would always be the center point here. And then on distribution 2, you can see there's a much greater spread of variation from the mean. So make sure you put some notes in your page about this, so the different types of distribution and the information about where the mean would be. So I asked you at the start when we were looking at those the height of females. I want you to think about what the range would be. Now, when we calculate a range, sometimes we can start to see that it isn't as useful as we'd like. Now, have a look at this range here. What problems can you see with this range? Pause the video, write down in your notes the problem. It's not a good representation. If this was going to be on one of those graphs that we just showed there, actually it's not a good spread. There's a very high number at the end. That's called an outlier. So an outlier is a number that doesn't really fit, and it really skews the range in this particular example, because you would think that there would be a big sample size when you can see it goes to the range is from 61, but actually the vast majority of the data, I know it's not a lot of data, but the vast majority of the data is at the very lower end of that spectrum. So a key thing to write down here then in your notes is that an outlier is an observation that lies an abnormal distance from other values in a random sample from a population. So pause the video and write down the information in the blue box so you know what an outlier is. So instead of using a range, we sometimes in biology will use a standard deviation. Standard deviation is much more useful because it actually takes into account every single piece of data. It still includes the outliers, because like I said in the previous example, when we had the females, yes, some females are very, very tall, but they're very different from the average. So this is what a standard deviation bell curve looks like. So assuming that the distribution is normal, like this bell curve here, then 68% of your data will fall around the mean, 34% on each side of the mean. 2 deviations from the mean gives us in total 95% of our data falls in this section here. So 98% of all your data will fall within 2 standard deviations of the mean. So this is where your 1 standard deviation is, your 34%. You can see that 95% of all of that, so all of this here is your 95%, that falls within the mean. And then you've got your very, very small sections here. Not much of your data will fall in these categories here. They're not close to the mean. So I suggest that you draw in your notes a copy of this lovely bell curve here with the 68, 95 and 99.7%. So that's your final third standard deviation. Standard deviation just means how much does your data vary, so the variation part, from the mean, the standard variation for that particular set of data. So let's go back to our female population then. Now, what we've got here is, like I say, the average height is 63.8. I'm just going to round that up to 64 for this example, just because it makes the maths a lot easier and a lot easier for you to understand at this stage. So I'm going to put a line in here to show me where my mean is. So average height then of females in the UK is about 64 inches or 5'4" inches. So somebody's already done the standard deviation for this, but the standard deviation is 2 inches. So 68% of the population will fall within these ranges here. The 68% of the population will be between 62 inches and 66 inches. And then we've got here the standard deviation after that. So 95% of the population will fall between 60 inches and 68 inches. And I'm sure if you asked any female members of your family, the vast majority of them would fall between 5 foot and 5'8". So that's 95% of our population falls within those. People that are below those numbers there, they fall into the next category. So another 2 down from that would be 58 inches, so 4'8", and then at the other end here, 70 inches would be 5'10". So most women will fall in those categories, but then you do have the extremes of that, and that's what these are here, and that is your last little category here of being 0.3% of the population, and 0.3% of the population of females in the UK are under 4'8". So if you want to make a note of that, you can do, it's entirely up to you, but it just helps explain it with some numbers in comparison to the last slide. So standard deviation is a way of showing the spread about the mean. It is less affected by outliers and it uses all the observations. So it's more useful than the range when we're doing scientific experiments and receiving data. So you've got a thin curve here, values remain close to the average, and that would mean a very small standard deviation. And then you've got over here a fat curve where we might see that there's a much wider spread in the values from the average. I would add some notes on there about the difference in the curves in relation to standard deviation.